This is an overview of the concept of static friction for AP Physics 1. And static friction is the type of friction that keeps things from moving. So everything is stationary. The other type of friction is called kinetic friction. That's when things are sliding, and we'll look at that later. So we'll start by looking at this video. And in the video, we have a smart cart with a force sensor that's attached to this wooden block. And we're going to pull gradually with the smart cart. And up above, we'll see a graph of force versus time. So let's just watch this video. And now we're going to change the situation. We're going to add some mass bars to that block and see what happens now. So here's a screenshot of that video. And what we saw is that as we were pulling, at first the block didn't move because friction could keep it stationary. But when we reached a certain force, friction couldn't hold it still anymore and the block started to slide. So one thing about static friction is it can be any value, any magnitude up to a certain maximum point, and then something will start to slide. And you can see it's really consistent, right around a little bit above 2.5 newtons. Every time we pulled with more than 2.5 newtons, the block started to slide. When we added some mass to it, which increased the force of gravity, we saw the same basic situation. There was a certain force that friction could not keep that thing stationary anymore, a certain maximum force of friction, but it increased after we had added mass bars to the block. So when we think about static friction, it depends on two values. One is the normal force. And you might be thinking, well, didn't we increase the force of gravity? And we did, but the force of gravity, when we increased that increased the normal force between the wooden block and the track. And the reason we don't use gravity instead of, or the reason we use normal force instead of force of gravity is because in this case, normal force and force of gravity are the same, but they aren't always. So on ramps or in situations where two things are pushing together in a different way, not because of gravity, in those cases, it's really better to think about friction as occurring because the two surfaces are pushed together, and normal force is a great representation of that force, or a great way to describe that force. The second thing that friction depends on, and we didn't see it in these videos, is the two materials. So if it was some other material other than a wooden block on a metal track, we would see different amounts of friction. So when we calculate the force of static friction, we have to take the materials into account, and we do that through a value called the coefficient of friction. And that's just a number that describes how many newtons of friction you get for every newton of normal force. And so what all that comes down to is an equation for the force of static friction. And those are subscripts, they come out a little big. But so the force of friction static is less than or equal to the coefficient of static friction times the normal force. And so the reason it's less than or equal to is because the force of friction can be any value up to that maximum value, which is the coefficient times the normal force. So that's an easy one to get confused. Friction doesn't have to be at its maximum value. It can be any value up to that point. So let's take a look at a practice question or an application question of this. We have this box sitting on a table. There's a string attached to the box that goes over a pulley, and from the rope there, the string, there's a bucket hanging there. And we want to know, does this remain stationary? So let's take a look at this problem. So in this question, we're trying to figure out if this box on the table will start sliding because the bucket is hanging off the side of the table by that string. And we have a coefficient of static friction of 0.3. So let's start this by assuming that the block is not moving. And that would mean that we have a situation where all the forces are balanced. And so if that's the case, if we look at that hanging bucket, we have a force of gravity down acting on that bucket, and we have a force of tension up. And if it's stationary, that means that the total force acting on the bucket in the y direction is 0, and that means the force of gravity equals the force of tension. And we can calculate the force of gravity. That's m times g, which is our 2 kilogram bucket, times 9.8 newtons per kilogram, and that works out to be 19.6 newtons. So that would tell us the force of gravity, which would also be the force of tension. So if we come up here to that box, if we draw a force diagram for the box, if that's standing still, we have a force of gravity down, we have a force of tension up, and we have, oh, sorry, not tension, a normal force up, and we have that force of tension to the right. And if it's not moving, there must be a force of friction going the other way. And so, again, what can we calculate? Well, we know the force of tension, if it's standing still, is 19.6 newtons. The force of gravity is m times g. That's going to be 10 kilograms times 9.8 newtons per kilogram, and that works out to be 98 newtons. If the forces on this are balanced, that would mean the total force in the y direction is 0, and that means our force of gravity, oops, I didn't write that clearly, total force in the y direction equals 0. That means the force of gravity and the normal force are equal, so our normal force must also be 98 newtons. So we can write that right there. So what about the force of friction? Well, we have an equation for the force of friction. I'll go ahead and write that over here. Force of friction is less than or equal to the coefficient of friction times the normal force. And we're looking at static friction in this case because it's not moving. So the force of static friction is going to be less than or equal to the coefficient, which is 0.3, times the normal force, which is 98 newtons. And if we do 0.3 times 98, we get 29.4 newtons. And a common mistake, sometimes people calculate that and they say, okay, I know that friction is 29.4 newtons, and it's not. What we have to remember about that equation is that this value tells us the maximum force of static friction. So static friction in this case can be anything up to that value, and it'll match whatever it needs to match. So if we look at this, we calculated that if it's standing still, that bucket is going to exert a force of 19.6 newtons of tension force on this block. Friction can take anything up to 29.4 newtons, and so that means that we haven't maxed out what static friction can do, and the box will remain stationary.